Good evening and welcome to week 12 meteorology. This is week 12 meteorology video on global climate. And this video, all the information pertaining to it can be found in chapter 12 in either the 7th or 8th edition of the Essentials of Meteorology, an Invitation to the Atmosphere. So either the 7th or 8th edition, you will find the information, the chapter on global climate in chapter 12. All right, so let's go ahead and get right into tonight's lesson by starting with the introduction. Different climate types. That's how we're going to start things off tonight. We're going to talk about microclimate. What is microclimate? Very near the ground. It covers a very near the ground in a smaller zone. Anytime I say micro, think smaller, where surface properties are consistent. Mesoclimate, regions such as forests, valleys, beaches, and towns. Meso is kind of like medium scale, okay? And then you have macroclimate, macro meaning larger area. Macroclimate covers a large state or a small nation. And then finally, we can even go all the way out to the global level, and we call that a global climate, which covers the entire Earth. So there are many different climates around the world, okay? And one of the main driving forces that control what type of climate an area receives are what's known as climate controls. And some examples of climate controls are latitude, land and water distribution, the ocean currents, prevailing winds, pressure areas, mountain barriers, and altitude. How high above sea level is a specific location? The first thing I'll talk about is latitude. Okay, latitude is the distance north or south of the equator. Okay, and the further north you go in latitude, the greater the variability in the overall weather or climate at that particular area. If you're closer to the equator, if you live on an area that has a closer latitude, a latitude close to the equator, then the weather is pretty much consistent. The climate's pretty much consistent from year to year. But you get a wider variability in the climate the further north away from the equator you get. The land and water distribution, this goes back to the fact that land heats and cools 5 times quicker than water. So if you live, for example, in the middle of a continent, like let's say for the United States you live in Nebraska, you're right in the middle of the continent, okay, the North American continent, the United States. You are going to have much wider variability in your climate, in your temperature, for example, between the coldest time of the year and the warmest time of the year, because land heats and cools off so much more quickly. Whereas if you are living in a location next to a large body of water, either on the Pacific coast or the Atlantic coast, you are going to have smaller ranges in temperature changes. There'll be smaller ranges in temperature overall through the course of the year. So land and water acts as more of a modifying influence on the temperatures. So you don't have such a large difference between the coldest and warmest times of the year. Ocean currents has to do with what kind of current do you have offshore where you live. If you live in California, for example, you have the cooler California current that comes down from the north. That cooler California current is going to have a modifying impact on your climate. You may be drier and cooler due to that cooler ocean current, the California current right offshore. Whereas if you lived on the east coast of the United States, where you have the much warmer Gulf Stream current, much warmer currents in general, you're going to have very hot and humid summers, and you're going to have modifying impacts to your colder continental polar air masses in the wintertime. Prevailing winds, this has to basically do with the fact that we in the United States live in the mid-latitude westerlies in that particular wind belt, so we get winds in all the weather systems coming from west to east. Pressure areas, pretty self-explanatory. Do you live near an area that typically receives lower pressure or higher pressure? And this is on a global scale now. If you live near the equator, equatorial areas of the world, you're going to have a lot of rising air, hot, humid, moist air, and it's typically dominated by lower pressure and thunderstorms at certain times of the year. Whereas if you live in the polar areas, you may be dominated or influenced by higher pressure and much colder air masses. Mountain barriers, mountains play a major role in the climate of an area. For example, if you live on the windward side of a mountain, you're going to have a cooler and wetter climate. And if you live on the leeward side of a mountain range, you're going to have a much drier and warmer climate. And that has to do with what we learned about earlier in the course. With rising air up the windward side of a mountain slope, the air rises, it cools, it condenses, it forms clouds and precipitation. Whereas on the leeward side, downwind of the mountain, you have sinking air motion. Whenever the air is sinking down the leeward side of a mountain range, it dries and warms out, and you have a much different climate. And then altitude. How high are you above sea level? How close are you to sea level? If you're in a location that's at higher elevations like Denver, Colorado at 5,280 feet, the Mile High City, you're going to have a much different climate than, say, New Orleans, which is sitting at sea level. So just some of the climate controls to really keep in mind and how climates are shaped, how the climate is shaped at different locations around the world. Global temperatures, isotherms are lines of equal temperature. So the isotherms are lines of equal temperature bend due to land heating and cooling, ocean currents, and upwelling. All of these things impact the way the lines of equal temperature, the average temperatures for the climate, how they bend and how they change shape. Global precipitation. Precipitation is most abundant where the air will rise, and it's least abundant where it sinks. Moving on to the next slide. Here's an example of a map showing you the lines of equal temperature, the isotherms. Each one of these lines, these are in degrees Fahrenheit, and so you can see where the 80-degree isotherm generally is situated throughout the course of a year across the world. You generally have it extending from Central America over northern South America into Africa, over to the tropical areas of Papua New Guinea, some of those islands, Singapore, the city of Singapore is right there near the equator, so they have fairly warm temperatures year-round. Northern Australia. And then as you go northward or southward, the further away you get poleward, away from the equator, the lower the temperatures are. But again, notice the bending, like we just talked about the bending of these isotherms, these lines. You notice how they bend upward over the oceans, and they bend downward over the land masses where, again, the land heats and cools much more quickly. So you get a bending down over the continental land masses, you get a bending up of the isotherms over the ocean areas of the world. So a world with many climates. If we were to look at the overall latitude belts and whether we have high or low pressure areas or systems in those specific latitudes, take a look at this chart. We're showing you the up and down motions associated with the various latitude belts, the three-cell theory of winds. You generally have rising air motion at the equator, about 0 degrees latitude. That results in a lot of thunderstorms, a lot of rain shower activity, where the heating is the greatest. And then you have sinking air motion at 30 degrees latitude, 30 degrees north or 30 degrees south of the equator. There's sinking air motion, which results in those subtropical highs, and that results in much drier conditions when the air is sinking. A lot of our Mediterranean climates, like Italy, they typically enjoy the sinking air motion at around 30 degrees latitude. They enjoy a Mediterranean type climate because of that. At 60 degrees north and 60 degrees south latitude, you get rising air again, as you have the polar front typically average position around 60 degrees latitude. So the air rises and it cools, it condenses, it forms clouds and precipitation there. And then the air again, once again, it sinks at 60 degrees, or rather 90 degrees. The air is sinking at 90 degrees north or south of latitude, and that is at the polar areas, the North and South Pole, and you typically have clear weather at those locations, and that sinking air motion results in the clear skies. And below the diagram, there's a description there that talks about, at the equator, all seasons are wet. Just north and south of the equator, you get a description that says wet summers and dry winters. And then at 30 degrees latitude, where you have the subtropical highs, the air is always sinking, so you get all seasons are dry. This is where some of the world's deserts are located at 30 degrees latitude, such as the Sahara Desert. And then you get the Mediterranean climates, like Italy, for example, where you get the really dry and fairly hot summers replaced by the wetter winters. Okay, so you have a wet and dry season in the Mediterranean type climates. Southern California, another great example of a Mediterranean climate. They get most of their precipitation during the winter months in California, especially Southern California. And then at 60 degrees latitude, you typically have a lot of precipitation, a fairly wet climate, all seasons wet. And then up at the polar areas, 90 degrees north and south with a polar high, you typically get all seasons are dry. Moving on to the next slide, we're looking at just various, we chose various locations across the United States. We're showing you San Francisco, California. We're showing Kansas City, Missouri, and then Baltimore, Maryland. And all these three cities are located at almost the same latitude. So San Francisco is at 37 degrees north latitude, Kansas City 39 degrees latitude, and then Baltimore, Maryland 39 degrees north latitude. And what I'm showing you is the precipitation bar graphs. You notice what's happening in San Francisco. Their amount of precipitation, their bar graphs, those bars are much higher in the wintertime, anywhere from November through about March. That's when San Francisco gets the majority of their precipitation. Look how the precip drops off, that image there on the left, the bar graph on the left for San Francisco. Almost next to nothing for precip in the May through the September timeframe, next to nothing. You move over due east, and in Kansas City, Missouri, more of a continental climate, you're getting some sort, at least 1 inch of rain, 1 inch of precipitation each month, basically, January through December. The precipitation maximum in Kansas City is in the summer, with usually scattered convection and thunderstorms. And then look how evenly distributed the precipitation is on the right, the bar graph there, Baltimore, Maryland. Precipitation is abundant all year long. Okay, so different locations can have different types of precipitation, whether a dry or a wet climate. Taking a look at the next slide, we're looking at, we're comparing the windward and the leeward side of mountain ranges. We talked about mountain barriers being one of those climate controls, and this is proof of it. If you look at a city such as Quileute, Washington, if you're looking at Quileute there on the left, that's their bar graph of precipitation. They get high rain, annual rain and precipitation totals, 134 inches of rain on average a year. In that particular area. And then you look on the leeward side, and Port Townsend gets only 18.4 inches. And you know what? These cities are not that far apart, but guess what? Quileute, Washington is on the windward side of the Olympic Mountains, whereas Port Townsend is on the leeward side, where the air typically sinks. So mountains play a major role in the type of climate an area receives. And then I'm just showing you the overall motion of how the air flows up and over these mountains. If we were out in the California area, if you were closer to Santa Cruz, California, you get some elevated, they call them the coast range mountains, between Santa Cruz, San Jose, and then Los Banos. And you'll notice the precipitation, the little shadow there at the bottom. That mirrors the elevation, doesn't it? It's almost like the average precipitation, you have like a precipitation curve, You see the higher precipitation averages on the windward side of the Coast Range Mountains, as well as the windward side of the Sierra Nevada Mountains as well. And then on the east side, look at the bottom right portion of this chart. It shows a major drop-off in annual precipitation because you're in the rain shadow of the Sierra Nevada mountain range, where by the time you get to Tonopah, Nevada, Bishop, California, and Tonopah, Nevada, you're next to nothing for annual precip. So mountains play a major role in climate controls. All right, so now we're going to introduce you to what's known as the Köppen classification, climate classification, the Köppen system. The Köppen classification system was developed in 1918 by Vladimir Köppen, and Köppen related vegetation and climate to predict climate types without even any climatological data. So he looked at the vegetation and he classified his climates into these groups: the tropical moist climates, the dry climates, the moist mid-latitude climates with mild winters, and then he has the moist mid-latitude climates with severe winters, and then the polar climates. So these are the 5 areas, the 5 classifications that Köppen used relating vegetation and climate. No climatological data at all. So let's take a look at the graphic here for the climate classification system, the Köppen system. All right. You look at the pressure system patterns here. Just in general, you see the red lines there in the center of the diagram. That indicates the average position of the intertropical convergence zone. The intertropical convergence zone is an area where both the northeast trade winds and the southeast trade winds meet up and converge, and air is always rising, okay? Wherever you see those 2 red lines there. I'm showing you the average position of the ITCZ in July and then the ITCZ in January. So you get a lot of precipitation, a fairly tropical, it's a very moist tropical climate, very tropical in nature. The green shading indicates that. Okay, so you see where the ITCZ red lines are, and you have a tropical climate in those green shaded areas. Now you go north or south of the ITCZ, you start getting into those subtropical high pressure systems, sinking air motion. Look at where the blue H's are over the oceans in this diagram. That's where the air is sinking around 30 degrees latitude, both north and south of the equator, and you get some of the world's largest deserts there, such as the Sahara of North Africa, the Australian desert, the Kalahari Desert of South Africa. You also get the Gobi Desert. Okay. So high pressures, sinking air motion around 30 degrees north or south latitude. Look at the yellow areas there on this map. That's your dry climates. And then the oranges colors indicate moist, mild winters. So from the southeast U.S. up into New York City or so, you get more of a moist, mild winter. That's the orangish colors. Look at Western Europe as well. And then the bluer shadings indicate moist, severe winters. So a lot of precipitation, but much colder in the bluer areas. Those would be the higher northern latitudes of the northern hemisphere. And then white areas indicate polar climate, and then you even have a little bit of a lighter brown color, and those are the climates that are created by mountains, so mountainous climates. So now we're going to break down all these climates here for the lesson. We'll start with the tropical moist climate. This is Group A. The general characteristics of this climate is year-round warm temperatures with abundant rainfall. Okay. The extent is generally north and south from the equator to about 15 to 25 degrees latitude. And this is where the intertropical convergence zone it generally moves between these latitude lines. The major types of the tropical moist climates, the Group A, we have the tropical wet climate, which is grouped as an AF climate. Notice that every climate has a couple letters associated with it. So tropical wet climate is an AF, tropical monsoon is an AM climate, and then tropical wet and dry would be the AW climate. Okay, and that would be associated with your savannas. So taking a look at the, and you can look at this in the in your textbook as well, but these are the classifications of the different climates around the world. So you can please feel free to look at these classifications. The legend on the bottom left explains what type of climate it is, and then the appropriate abbreviation. Look at some of the patterns of vegetation that you'll see with this tropical moist climate. You get really lush forests, a lot of green in this forest. We have quite a diversity of living organisms in these rainforests, and the diversity actually is the greatest in rainforests, by the way. All right, so if we were to take a location such as, this looks like Iquitos, South America, the annual temperature is about, it looks to me the annual temperature range is only 4 degrees Fahrenheit. So this is what I was talking about. The mean average temperature throughout the year is 77 degrees Fahrenheit, but the annual temperature range is only 4 degrees Fahrenheit. I'm showing you, basically, I'm telling you that there's not much of a difference when you're closer to the equator between the cooler and the warmer times of year. In this case, there's only a 4-degree temperature difference between the coldest and the warmest month. At the bottom, I'm showing you the total precipitation, and it is a lot. It is a lot of rain throughout the year in Iquitos. Look at the bar graphs. There is a little bit of a drop-off in June, July, August. But overall, you're looking on the left there at inches. So there's quite a few months that are 8 inches plus. Only 3 months are about 6 inches or less in Iquitos. So a very wet tropical climate. Now look at something like this. If you were ever to go take an African safari, this may be some of the landscape you would see where all the wild animals are kind of just roaming these lands. This would be an example of a savanna type climate, a wet and dry type of climate. So what would it look like for a wet and dry climate? Okay, so we'll take an example of Timbo in Africa. Timbo in Africa, its mean annual temperature in the city is about 74 degrees Fahrenheit, and its annual temperature range is a little bit more now, 10 degrees Fahrenheit. So a 10 degree Fahrenheit range between the coldest and the warmest months, and this is due to the drier season. When you get the drier air masses to come in, they heat and cool 5 times quicker than the moist air masses. And at the bottom, I'm showing you the annual total precipitation for Timbo, Africa, is about 64 inches of rain. But notice the distinct rise or increase in the annual precipitation, especially during the months of July, August. Those are the biggest precipitation producing months in Timbo, Africa, because the ITCZ, the Intertropical Convergence Zone, that red line there, is fairly close by, and that results in a lot of convective type weather, heavy rain showers and thunderstorms quite frequently in Timbo. Now we'll move on to a discussion on the dry climates, and we call the dry climates Group B. The general characteristics, there's deficient precipitation most of the year. The potential evaporation and transpiration exceed precipitation. So we're having more moisture being evaporated from the ground as well as from plants. Transpiration refers to evaporation of water from plants. The extent we typically have in Group B, the dry climates, we typically find subtropical deserts, which extend roughly between 20 and 30 degrees latitude in the large continental regions of the mid-latitudes, and they're often surrounded by mountains. So when you think of dry climates Group B, think of that area where they have subtropical high-pressure systems, the vertically sinking air. As the air sinks vertically, it dries out and warms, and you get some of the largest deserts of the world. The major types of dry climates, the Group B climates, are the Arid, the BW climate, and Semiarid, the BS climate. So the first one we're going to start with, here's a picture of a location that has more of a semi-arid climate. Okay, so when I look back here and say semi-arid, okay, so not all of the year is completely dry. there are some moist times or wetter times of year in this location. So in the image here, it's kind of hard to see, but you can see a little bit of, you have vegetation still. It's somewhat green. That tells me that they do get some form of precipitation to go ahead and provide to those plants in this image. Now let's look at a truly arid location. Well, cactus, We look at a cactus plant. Typically we define that in a more arid desert type region. So this would be an example of a arid or this is arid BW climate right here. Okay? So the global pattern of climate, if we were to look at Phoenix, Arizona, for example, right? We can consider Phoenix, Arizona more of a semi-arid climate because they do get a little bit of rain. Okay, it's not completely dry year-round, all right, in Phoenix. They do get an uptick in rain a little bit towards like February, March. Sometimes the winter storm systems come in off California, off the Pacific into California, and spread moisture into Arizona as well. During the winter months, you can also get what they get kind of like a monsoonal moisture. You get moist southeasterly winds in the summertime over Phoenix, and you have a bump up in precipitation amounts in July and August as well. So in the winter months in July and August, it's somewhat moist, somewhat wet. What's amazing about Phoenix, Arizona, if you look at the red line there, that is their average temperature per month. And you can see how hot it gets in the summer. The average temperature July and August is above 90 degrees Fahrenheit. That's the average. The mean annual temperature in Phoenix overall, however, is about 75 degrees Fahrenheit. And the annual temperature range in Phoenix in a semi-arid climate is 39 degrees Fahrenheit. So there's a 39 degree Fahrenheit change between the coldest and the warmest months. So that's pretty considerable. Here is an example of a semi-arid region. Again, you see some of the plants there on the ground that are still able to survive. I'm not seeing true cactus here in this particular area. So they do get a little bit of moisture here around Phoenix. You may see something similar to what I'm showing you here in a semi-arid climate. Right, now let's move on to talk about a place like Denver, Colorado, where the mean annual temperature is 50 degrees Fahrenheit, and the annual temperature range in Denver is a whopping 44 degrees Fahrenheit. You talk about extreme temperature changes. If you ever get a chance to visit the leeward sides, the front range of the Rockies, because of the downward motion when you get those strong Chinook winds, those warm, dry, downsloping winds, they call them Chinooks out there, you can have crazy temperature swings. So Denver has quite a range in temperatures throughout the year. Average high of about 30 degrees in January, all the way up to about 75, 76 July and August, and then drops back down to about 30 or slightly below 30 by December. The precipitation for Denver, they actually get the most of their precipitation in the month of July, believe it or not. When you get upslope wind flows, you get convective storms, thunderstorms that develop along those mountainous areas to the east of the Rockies. Moving on to the moist subtropical mid-latitude climates now, we're going to go to the Group C climates. The general characteristics of moist subtropical mid-latitude climates is it's humid with mild winters. So as an example, I want you to think about, for the United States, think about Georgia, think about South Carolina, North Carolina, even into Virginia. Think of the southeastern United States as a whole. Very humid summers, but the winters aren't super cold either. They're fairly mild. If you look at the average temperatures for cities like Atlanta, Charlotte, if you look at Birmingham, Alabama, it's not super cold. It is fairly mild winter. Now the extent is the eastern and western regions of most continents, generally from about 25 degrees to 40 degrees latitude. The major types of climate classifications under this, the Group C climates, would be humid subtropical, it's abbreviated CFA, marine, CFB, the dry summer subtropical, and then the Mediterranean. The Mediterranean climate is abbreviated CS. So let's take a look at a couple cities within that particular range. Climate classification, Mobile, Alabama. All right. Mean annual temperature in Mobile, Alabama is about 67 degrees Fahrenheit, and the annual temperature range is about 28 degrees Fahrenheit. So it's not too drastic throughout the year as far as temperature swings. Of course, Mobile sitting on the Gulf of Mexico. That Gulf of Mexico water provides a modifying influence on the temperatures. And the bottom here shows total annual precipitation. 68 inches of rain in Mobile, Alabama on average. So that's quite a bit. But look at the bar graphs. January to December, notice one thing, those blue bars, they're fairly evenly distributed. So there's not a wild swing in, there's no dry season here at Mobile in that particular location. There's no like wet season. It's pretty evenly distributed throughout the year, the amount of precipitation. Another city we could look at is Port Hardy. It looks like it's on the Canadian coast there, British Columbia coast. The mean annual temperature there, it's a city located on the Pacific Ocean. Mean annual temperature is only 47 degrees Fahrenheit because now we're going up, we're increasing our latitude, we're getting further north away from the equator, and then additionally we're basically in a city situated on cooler waters. The red line indicates the changes of temperature throughout the year. Notice that curve is not as great as it was for Phoenix, for example. The annual temperature range here is about 19 degrees Fahrenheit. But look at the bottom, the precipitation amounts per month. Looks to me like November is the winner. It has the most precipitation in the month of November, up to 12 inches on average. December is a close second, as well as January, just under 10 inches of precip each of those months. And then look at, by the time we get to summer though, look how that precip drops off. July being the driest month for Port Hardy there in Western Canada. And now if we compare a couple other cities, let's look at San Francisco, California, and Sacramento. Okay, the precipitation bar graphs at the bottom for both cities, you notice one distinct trend. They get their precipitation in the wintertime. All right, that's when you get those storm systems to come in off the Pacific Ocean. The jet stream takes a much further south dip, and so you can see that the precipitation is much greater in the winter months for both San Francisco and Sacramento, California. One difference you're going to notice, one major difference here between these two cities, look at the red line. Look how your red line in San Francisco, your temperature line, between January to December, it's not as drastic. The curve isn't as great. It's more flat for San Francisco on the left. So your temperature range for San Francisco, your annual temperature range in San Francisco, due to the modifying influences of the cooler ocean current offshore, with San Francisco being right on the water, there's only an 11 degree Fahrenheit annual temperature range. And then you can move a little bit further inland into Sacramento, into that valley, and it's further away from the modifying influences of the cool California ocean current, and you get a much larger spread in temperatures between January and then July and August are the hottest months in Sacramento. Your average high is much greater at that point. You have a 31 degree Fahrenheit annual temperature range in Sacramento, only an 11 degree Fahrenheit annual temperature range in San Francisco. So that's the big difference. The modifying influences, one of the climate controls we talked about was the ocean currents, the modifying influence of water. Looking around San Francisco, and as you move further inland away from the water, you get vegetation that looks like this. There are a lot of hills in California like this. There's a little bit of green vegetation on some of these hills, so that tells me they do get some precipitation at this particular location. Now we'll move on to the discussion of the next climate classification. We call this the moist continental climate, Group D. The general characteristics of this Group D, the moist continental climates, is for warm to cool summers and cold winters. Winters are severe in this climate belt with snowstorms, blustery winds, bitterly Arctic cold air, climate controlled by a large continent. The extent of the moist continental climates of Group D is north of the moist subtropical mid-latitude climates, and the major types include humid continental with hot summers, and that's abbreviated DFE climate, or DFA climate. The humid continental with cool summers, the DFB climate, and the subpolar climate, that's abbreviated DFC. So let's move on and, oh wow, take a look at that pretty picture. That is an example of some deciduous trees changing color in the autumn, in the fall, and wow, that's beautiful. I think I see some maple trees in there. Look at the forest floor being littered with a lot of foliage, a lot of leaves. This is an example of an area that would fit this classification, the moist continental climate, Group D. Okay. Let's compare a couple cities that are in this particular Group D climate, the moist continental climates. We can compare Des Moines, Iowa on the left to Winnipeg, Canada on the right. Okay, so the red lines indicating the temperature ranges throughout the year, January to December. Notice the sharper curve for Winnipeg, Canada. The annual temperature range in Winnipeg is 65 degrees Fahrenheit. Now that is mind-boggling. Your average temperature in January in Winnipeg, just about 0 degrees Fahrenheit. And then about 66, 67 degrees Fahrenheit in the warmer summer months, July and August. And then look at the curve, how it drops off drastically again in Winnipeg, all the way into December on the far right. The precipitation in Winnipeg, they don't get as much precip as, they only average 21 inches a year. Whereas on the left there, we've got Des Moines, Iowa, which gets 36 inches of rain on average a year. Look at the curve for Des Moines, the temperature curve on the top, on the left-hand side. Annual temperature range of about 54 degrees Fahrenheit, so pretty significant still, even for we're talking about continental climate. There's no influence of water to modify the air masses, so you get a larger temperature range between the coldest and warmest months. And another example would be Fairbanks, Alaska. And you want to talk about a sharp temperature curve. Look at this one. From the coldest month, average about -9 Fahrenheit in January, all the way up to about 61, 62 degrees in the summer months. And then it comes crashing back down again. That red line slopes right back down again on the other side of the warmest time. A lot of this has to do in Fairbanks with, the amount of sunlight they receive throughout the year. They're pretty far north in latitude, so they have a wide varying degree of daylight and darkness. Okay, and then at the bottom, I'm showing you the annual total precipitation in a place like Fairbanks, Alaska. It's only 11 inches a year. We look at, you ever watch Christmas movies and they show you where Santa lives at the North Pole, and you always see snow on the ground, and sometimes they portray major snowstorms at those latitudes, but guess what? They really don't get much in the way of precipitation annually the further north up towards the North Pole you get. And in northern Canada and northern Alaska, because there's just not a lot of moisture to work with up there. Okay. Here's a beautiful scene. We're looking at some pines. We're looking at the climate type, the moist climate type. Go back here. They're just beautiful. What a beautiful scene that is. All right, now we move on to the polar climates, Group E. The general characteristics of these climates are year-round low temperatures. Extent is northern coastal areas of North America and Eurasia, Greenland and Antarctica. And the major types of the polar climates, Group E's, are the polar tundra climate, the ET climate, and then the polar ice caps climate, the EF climates. All right, so if we take a look at Barrow, Alaska as one of those polar climates, it's well up there in latitude, well away from the equator. The mean annual temperature is only 12 degrees Fahrenheit. 12 degrees Fahrenheit for Barrow, Alaska. The annual temperature range, quite a steep slope to the red line here, so that's a wide range of temperatures throughout the course of the year. 55 degree Fahrenheit temperature range throughout the course of the year in Barrow. And then look at the very little precipitation that Barrow gets. July, August are the wettest. I shouldn't say wettest. It's probably frozen precipitation, but July and August have the most precipitation, and then the rest of the year it's hard to get any precipitation, anything to fall from the sky in Barrow. Here's an example of a polar climate. All right. Notice the higher terrain in the background of this picture. It's a really nice picture. Very nice picture. And then I'm taking you to Greenland. Greenland, an example of another polar climate. The mean annual temperature range of negative 22 degrees Fahrenheit. Ooh, that's cold. And the annual temperature range is 65 degrees Fahrenheit from the coldest and the warmest months. And again, annual total precipitation in the middle of Greenland, 4.3 inches. That's it. Throughout the whole year, they only get 4.3 inches of precipitation to fall from the sky in Greenland. The red line indicating that a significant temperature curve. You notice that July is the warmest month for Greenland, and it's only sitting, when I say warmest, I'm only talking about 12 degrees Fahrenheit above zero for the average temperature in July in Greenland. The coldest the coldest average temperature is in February for this location. It's Esmeet, Greenland. The average temperature in the month of February is negative 52 degrees Fahrenheit. So, wow, that's a very cold average temperature. So that's basically what the temperature should be around each day in the month of February. Just wow, incredible. All right, and then we have a special climate classification group known as the Highland Climates, and we just appropriately group these in a group H. H for Highland. There's a decrease in temperature because of altitude. We're talking about mountainous areas when we talk about Highland climates. They do say that mountains create their own weather, and they're not lying when they say that, because they really do. The great deal of variation in temperature, precipitation, and vegetation over a relatively short vertical change in elevation, that occurs with Highland climates. Okay, so there's a large variation in. You can see it by just walking trails. The vegetation may change rapidly. So here's an example of a vegetation change up a mountain here in the Highlands type climate. Check this out. At the base of the mountain here, you have grassland. If you were to continue to climb up this side of this mountain, you would run into chaparral, and then you'd have mixed conifer forests as you go up higher. The taiga, a little bit of a tundra landscape just below the base of the ice cap. So you can have Highland climate, you can have a wide range of vegetations due to the changes of air temperature, with of course air temperature being much colder the higher up you get. All right, so that wraps up the week 12 meteorology video on the global climates, the world climatic system. We talked about tropical climates, we talked about dry climates, we talked about middle latitude climates, and we talked about the Köppen classification system for climate. So we grouped our climates into various areas based on the amount of precipitation received throughout the year. Tropical climates are found in the lower latitudes closer to the equator. The noon sun is always high in these locations. Day and night are usually of equal length, nearly equal length throughout the year. Months are warm. There's no real winter season in these locations. For dry climates, they prevail where your evaporation from the ground and your transpiration, which is evaporation from plants, if that is greater than the amount of precipitation, you look at a dry climate. And then we looked at middle latitudes, which have distinct seasons, winter and summer seasons. We looked at that as well. Okay, that wraps things up on week 12 meteorology video on climates, and I hope you have enjoyed this information tonight, and I wish everybody a great day or night wherever you are or whenever you're watching this. Have a great day or night, everybody.